What happens if you fall into a black hole? This question, which seems straight out of a science fiction script, is actually a serious and fascinating point of investigation within theoretical physics. Black holes, those enigmatic celestial objects whose gravity is so intense that not even light can escape them, are among the most intriguing mysteries of the universe. By exploring what would happen to a human being crossing the event horizon of a black hole, we enter a realm where physics as we know it meets its limits, and scientific speculation takes the lead. From extreme time distortion to total cosmic isolation, and the fascinating yet terrifying possibility of transitioning to another reality, the hypothetical journey through a black hole challenges our understanding of the fabric of space-time. Current theories, based on decades of research and mathematical development, offer some predictions about what could happen. However, the nature of these astronomical objects still holds many secrets, suggesting that the universe may be even stranger and more wonderful than we can imagine. Shall we embark on this journey? The phenomenon known as spaghettification stretching is one of the most fascinating and extreme effects predicted by Einstein's general theory of relativity, occurring near a black hole. When an object approaches a black hole, it encounters an incredibly intense gravitational force. This force is not uniform. It is much stronger on the part of the object closest to the black hole than on the farthest part. As a result, the object is stretched vertically while being compressed horizontally, a process that resembles turning a piece of dough into a long, thin strand of spaghetti. The explanation for this phenomenon lies in the gravitational difference between two nearby points in an intense gravitational field. Technically, this is known as a tidal gradient. Near a black hole, these gradients are so extreme that they can stretch large objects like stars, or even humans if they were close enough. This stretching is not just a theoretical curiosity, it has profound implications for understanding the limits of matter and gravity. In the context of spaghettification, the structural integrity of any object subjected to such stress would inevitably be compromised. For a human, this would mean that even before crossing the event horizon of the black hole, the point of no return, the body would begin to stretch beyond recognition. This happens because the forces at play would far exceed the molecular cohesion holding tissues and cells together. Time distortion is one of the most intriguing and least intuitive concepts in Albert Einstein's general theory of relativity. This theory predicts that the presence of a large mass, such as a black hole, can significantly affect the flow of time. As an observer approaches a black hole, the intense gravitational force of the object causes time for that observer to pass more slowly, compared to someone in a region of space with weaker gravitational force. This effect is known as gravitational time dilation. To understand this phenomenon, imagine a clock moving toward a black hole. As the clock approaches the event horizon, the boundary around the black hole beyond which nothing can escape, it will start ticking progressively slower compared to an identical clock that remains distant from the black hole. This happens because gravity distorts the structure of space-time, a mathematical representation that describes gravitational influence on space and time. This time distortion is not just a theoretical prediction. It has significant practical implications, particularly in technologies like global positioning systems, GPS, which must account for Earth's gravity effects on time to maintain their accuracy. In the extremes of a black hole, these effects are far more dramatic and can lead to significant differences in time perception. Cosmic isolation in a black hole is one of the most extreme and solitary concepts in theoretical physics. This concept suggests that once an object, or in this case, a human, crosses the event horizon of a black hole, they are effectively cut off from the rest of the universe. The event horizon is the boundary around a black hole beyond which nothing, not even light, can escape. Once this boundary is crossed, there is no known way to return or even send information back out. This isolation is not merely physical, but also informational. According to the laws of physics as we know them, any information that enters a black hole is lost to the external universe, except perhaps in the form of Hawking radiation, a type of theoretical emission that has yet to be empirically observed. This means that, theoretically, if someone were to fall into a black hole, it would not only be impossible to return, but no information about their fate or condition could be retrieved or transmitted. This notion of cosmic isolation goes beyond the conventional human experience of loneliness or isolation, as it implies a complete and irreversible separation from all known universal contexts. It is a concept that challenges our understanding of connections and continuities in the cosmos. While in the macroscopic world we are accustomed to the idea that everything is somehow interconnected, isolation in a black hole presents a scenario where these connections are definitively severed. The idea that crossing a black hole could lead to another reality or universe is one of the most intriguing and speculative in the field of theoretical physics. This theory arises from the quest to understand what happens at the center of a black hole, in the singularity, where the known laws of physics no longer apply. According to some theoretical physicists, black holes could be portals to other universes or dimensions, an idea that challenges our conventional notion of space and time. This concept is supported by some interpretations of string theory and quantum gravity, which suggest the possibility of multiple universes connected by wormholes, hypothetical structures that allow direct passages between distant points in spacetime. Although wormholes and black holes are conceptually distinct, the idea of a black hole as a portal is based on the possibility that, under extreme conditions, conventional laws of physics could be altered in ways not yet fully understood. The transition to another reality through a black hole raises profound questions about the nature of the universe. If such a transition were possible, it would imply the existence of a cosmic structure far more complex than currently perceived. Moreover, it would open a vast field for theoretical exploration about how these different universes could interact, what the nature of their physical laws might be, and how matter and energy could be transferred or transformed in these transits. While the idea of falling into a black hole may seem more akin to a science fiction script than reality, the theoretical implications offer us a fascinating window into the extreme limits of known physics. These enigmatic celestial objects are not just points of no return, but are also crucial to our understanding of how the universe functions under its most extreme conditions. Through them, we explore the deepest mysteries of the fabric of space-time and confront the boundaries of what science can currently explain. Whether I have awakened your fear or fascination with black holes, the truth is that each new discovery brings us one step closer to unraveling the secrets of the cosmos. I encourage each of you to stay curious and questioning, participating in this ongoing journey of discovery. Don't forget to share your own theories and thoughts in the comments below. What are your views on what lies beyond the event horizon? If you enjoyed this dive into the depths of the universe, don't forget to leave your like and subscribe to the channel for more explorations and discussions like this one. Science is always evolving, and together we can continue to explore the wonders and mysteries that await us. Stay tuned for the next video, where we will continue to challenge the known and explore the unknown. Until then, keep your eyes on the stars.